are, as we were saying last, I think last week I talked about the Monty Hall 3 doors. We've kind of multiple regression, particularly the way we've addressed it, which is people talk about as the general linear model sort of approach. Is we're kind of at that crossroads of additional techniques now that can kind of build on that. One of those is path analysis was one of them, kind of but leading then to structural equation modeling. A second door, kind of another approach, is related to logistic regression and a situation similar to logistic regression where our outcome is no longer continuous. Notice everything we've looked at so far, we have an outcome measure that's a continuous variable. But there are things in life that are not continuous. Interesting things, particularly in education. Kids drop out of school. That's not you don't kind of drop out. You're in, you're out. You graduate. You graduate or you don't. You are enrolled in special education or you're not enrolled. And that's what logistic regression and related techniques get at. Before kind of moving into that, let's start with a simple illustration. This is not a logistic regression, but it's going to introduce us to a measure of effect that we see in logistic regression called the odds ratio. So this is a new sort of measure of effect that you will see in logistic regression. You'll see people talk about it if you look at an article where they're doing logistic regression. But to kind of understand where it's coming from, I think it helps first to do a very simple model. And you can calculate an odds ratio in logistic regression, or kind of in a simple case like this, we can do it directly in this 2x2 table. Let's say that I've sampled 200 youth, and I've sampled 100 kids who dropped out and 100 kids who did not drop out. So I've sampled 100 kids who dropped out, 100 kids who did not drop out of high school, and I've gone back and asked them, I've somehow gathered information from them, did their parent drop out of school as well? Their parent complete high school. There's lots of studies that parents don't complete high school if their kids are at greater risk of not completing high school themselves. And so we see among the kids who dropped out, about half of them had parents who dropped out and half did not. Among the kids who did not drop out, 10%, 10 out of that 100 had a parent who dropped out and 90 did not. The kind of language we'll talk about is we're retrospectively, in this case. I'm kind of going back retrospectively, figuring out if the parent dropped out or not. Based on this, we can calculate the odds that a child who dropped out had a parent who previously dropped out. So I'm asking again, what are for a child who dropped out, what are the odds that their parent previously dropped out? I've labeled these just to kind of help with the math here a little bit. So among the youth who dropped out, the odds that a parent dropped out is simply the frequency that dropped out, divided by the frequency that did not. Notice I'm not talking about a probability. The probability that their parent had dropped out would be 50 over 100, half of them. Odds are not probabilities. Odds are the number that did something and the number that did not. It's the yin and the yang. It's the flip of the flop, or the heads and the tails of the question. So the odds are 50 over 50, or 1. If you think of like Vegas, yeah, it's those kind of odds that we're talking about. Well, in fact, you can think of the whole thing, the language of the odds are 50-50 is kind of really summarized. It's even one or the other the chance are the same. Okay, so that's odds. Now, odds alone are kind of difficult to interpret. What does that mean, the odds are 1? Is that a big deal? That the child, if a student drops out, the odds that their parents dropped out are 1? Hard to make. What is that big or not? Hard to interpret odds on their own. So instead, what we do is calculate what's called an odds ratio, and the odds ratio compares the odds for 2 different groups. We look at the odds of the parent dropping out, or having a parent who dropped out, for the youth who dropped out, versus the odds of having a parent who dropped out for the kids who did not drop out. So kind of we're looking at the relative odds. What are the odds for these kids relative to the odds for those kids? The odds ratio, you know the odds for the parent dropping out for the kids who dropped out is A over B, right? It's the same for the youth who did not drop out, is C over D. And so the numerator here, that's the odds of the parent, of having a parent who dropped out if the kid dropped out. And this is the odds for the kids who did not drop out. If you kind of do the cross math, you'll often see this formula showing up, which may kind of seem weird. Why are you multiplying A and D? But it's just kind of flipping the division around. And you end up with the odds ratio of 9. And how we interpret that is the odds, I got it right here. If a youth dropped out, the odds that their parent also dropped out is 9 times that if a youth did not drop out, or relative to youth who completed school. Now that may seem kind of a cumbersome way, because am I really interested if the kid dropped out? Am I really interested in their parent dropping out? I'm probably more interested in if the parent drops out, what are the odds that the child will drop out, right? Rather than, you've already dropped out, I don't really care what your parents did. You already dropped out. I can't do anything with that. Versus if your parent dropped out, I know, and now I know you're 9 times, I know you're a bigger risk. I can work with that. Now, what's really kind of cool with the odds ratio, this is why this is one of the strengths of the odds ratio versus looking at probabilities. It's more difficult to do this with probabilities. Odds work, the math is cleaner with odds without getting into that. It is just as valid. Even though we're calculating this and we sampled kids who dropped out, kids who didn't drop out, what are the number, what did their parents previously do? You can also take that 9, that odds ratio of 9, and use it that if a parent drops out, the odds that their child will drop out are 9 times that of the odds for a parent who did not drop out. Which, if you really think about this, that may seem kind of crazy, because I sampled the kids this way, but I'm interpreting it this way. I'm interpreting it, if the parent drops out, the odds that their child will drop out are 9 times greater than if the parent did not drop out. We actually got like a 6-page paper somewhere. Chapin and I did a paper. We were wrestling with a reviewer that was arguing you can't do this. We actually went through the math, kind of showing that no, you can, and that's not even fancy on our part. People have done that long ago. That's why they do it. It was just someone unfamiliar with odds ratios that it's okay. But that really helps. That fact that you can interpret, it's the same number. Even if you sample the kids based on did the kid drop out, and you're retrospectively asking about what their parents did, you get the same number as if you had sampled the parents and prospectively followed them and did the odds ratio that way for that population, defining that population of kids is a little tricky so typically in these sorts of cases, this is how you'll see people talk about it, because that's the question we're interested in. If the parent dropped out, what are the odds that the child drops out? If the parent smokes during pregnancy, well, the mother smokes during pregnancy, what's the increased odds that a child will have some developmental disability? We do a lot of studies that way where we sample based on the outcome, retrospectively then look at the variables we're interested in, but then you're able to interpret kind of what the effect those variables had on your increased odds of that outcome, whether it's dropping out, not dropping out, being arrested, not being arrested, graduating, not graduating, all sorts of things. But what if the predictor, so in this case, this works kind of clean.